Hi, in this video we are going to go over the solution of the problem of finding k largest elements in an array. For example, I have this array called points, and I have these integers in it, and I want to find the three largest elements that will be here: 9, 12, and 10. So one nice solution is to go over all of the elements, and when I go over each element, compare it to the rest of the elements. So in that case, the time complexity will be big O of n to the power of 2, so which is very inefficient, and we don't want that. So the solution for this problem is going to use priority queue, and we are going to use min heap. And if you are not familiar with min heap, I highly recommend you to watch a very good YouTube video that I can put the link under this video, and that is actually by this channel, that Abdul Bari. So I highly recommend you to watch this video before watching this solution, so that if you are not familiar with min heap, if you are, we can start. So for doing that, so the solution that we are going to do, we are going to use a min heap and in Python. So for doing that, we need to import heap queue, and I'm going to make a list that this list is going to contain the elements of the heap. So I call that k largest, an empty list, and then the return of the function is k largest. So I'm going to return this list whenever I have correct elements in it. So for now, let's say for the beginning, I just add the first three elements of the list to that. So for I in range of 0 to k, which is 3. So to add an element to our heap, we just use the function heap push. So the first thing that we need to put in that is the list that contains the elements that for us is small k largest, and the items that we are going to use to add are the elements of the list points. So it's gonna be points element I, because we are looping over I. So it's gonna be 0, 1, 2. So we read the 0, 1, 2. Okay. So let's see what we get by now. So k largest okay. So let me run this. Nothing, because we didn't use the function. So I have to items, points, and k. Okay, good. So now, okay, so we see what we return, and also I just printed k largest here for you to see what we have so far. So at the beginning, I made a heap queue. I added 3 elements in it. So, and that is what we have so far. So the next step is that I have these 3 elements already allocated the heap. Then I start from here. Then I start from k plus 1 and go forward. Go forward and try to compare each element to my already nodes in the min heap. But the beauty of that is that in min heap, automatically, so I get the minimum. So I get 2 here. I don't need to go and compare to 9, 2, 5. I don't need to do that. So I just compare it to 2. So, and when I go, and if this 6 is larger than 2, then I replace it. So then when I come here, I just need to compare it to 3 elements. So let's see what happens. So we say for j in range of what? We had 0, 1, 2. Now we should start from the index 3, which is k, to the end of the list, length of points. Correct? So I'm going to go all of the elements. So let me just print. I like to print j just to see where we are when we work with that. So now is that comparison that we talked about. So now I want to come and say, okay, if point j, the new element that I have, is greater than the highest, the root of the min heap. What is the root of min heap? So in Python we can access to that by the first element of the list that recorded all of the nodes in a min heap. So I need to do this. So if you remember, k largest was the list we initially defined, and then we added 3 elements. So the first element of that is always going to be the minimum value in that list. So here that's gonna be 2. So I do that, and if you want to make sure what we have, so let me just print points j here, just for you see what point we added. If you want, I can just also, sorry, I just want to print a step by step to make sure that we understand what we are doing. Okay, so now I have that comparison, and we said, okay, if that point, I had this 3, if that point is larger, I have to replace it with the smallest things. So there is another function for that. So we say heap dot heap priority queue, heap queue, heap dot heap replace k largest. So you don't need to put the element, it knows that is going to replace the root, and the item is the item j. Let me also print k largest here, just to have a beautiful. Okay, I think we are good actually right now. So let's see what happens if I run this program. So okay, let's start from the beginning. So we had k largest 295. Initially we added to the k largest list, and that was fine. So, and then we go to j equals 3, and we say, okay, point at index 3 is 6. It's greater than 2. So I'm going to replace 2 in this list with 6. So my new list is 596. And you see that automatically the 5 is at the beginning, because that is a min heap function that does that automatically for you. So then I go for the next index, which is this one. No, none of it is not greater than any of them. So then I go for the next one. So sorry, the next one is this one, and then next one is this one. It's nothing until I get to the index 6, which is the element is 7. So when element point is 7, so that is greater than 5. So that needs to be replaced. So that is gonna be replaced with a 5, and you have 6, 9, 7. So always the smallest one comes to the beginning, because that is the root of the min heap. So, and the rest of them, it's not going to be sorted. So you will see in that video that the only things that is going to give you a heap is going to be the mean or max, is going to be the root will be the mean or max, not the rest of them. So, but every time you remove, you get the mean in the root. So next one, so we go to the index 7, then you have 12, again you replace, and at the end, so you have all 3 largest elements remained in your heap, because every time any element is larger than the minimum, that got replaced. So in this way, we are going to solve this problem much faster than a naive solution. And let's look at the time and space complexity of this problem. Okay, about the time complexity, we initially added k elements to the heap, so that's gonna be the big O of k here, and then we are looping over n minus k, and also we have heap replace. Heap replace is both heap insertion and heap delete, so each one of them in the worst case scenario they have log k time complexity, so we have 2 of that. So as a result, we have order of k and 2 times n minus k, that's because we are looping over n minus k, and times log of k. So as k is going to infinity, so in that we consider the limit of that, so it's gonna be time complexity will be the order of n times log of k. About the space complexity, so we made a heap with k elements, and as you remember here, so we had always the length of that will remain to k, so because of that our space complexity in the worst case scenario will be order of k. And this is the solution of this problem, and thank you so much for watching this video.